Okay, so we've been factoring stuff all week. You're supposed to take a test on this tomorrow, but that's not happening. Just had too many people gone. We're not ready, so we're not taking a test tomorrow. All right, that's next week's problem, huh? Yep. Yeah, test is next week's problem, but we'll talk about that later. Today we got to talk about, this is the last new thing I got to show you with factoring. Last new thing, and then we're just going to be practicing, okay? Special cases, basically like weird stuff that happens sometimes when you factor, okay? So let's do the easy one first. Let's say I have this equation, a squared plus 2a plus 1, and I'm told to factor it. You guys remember what the first thing you do when you factor is? Multiply what? Yeah, the first thing times the last thing. Remember, what's in front of this? A 1. So 1 times 1 is 1. You need two numbers that multiply to 1 and add to 2. 1 and 1, pretty easy. 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. Shortcut, right? Can I do the shortcut here? Why? Yeah, because the leading coefficient is 1. That's the fancy way we say it. But if there's nothing in front, you can do the shortcut. So I know that it's going to be a plus 1 times a plus 1. This is a special case. We call this a special case because the factors are the same. That's fine. Doesn't mean that you're wrong. Doesn't mean you messed something up. That can happen sometimes. Make a little bit of sense? Why don't you try one of these other ones? 2, 3, or 4. The factors should be the same, and that's okay. Don't let it freak you out. All right, this one. So you multiply first times last. It's 121. Two things that multiply to 121 and add to negative 22. It's kind of weird. You might not know this one off the top of your head, but do you know anything that multiplies to 121? 11 and what? 11 and 11. 11 times 11 is 121. What's 11 plus 11? 22. But hold up. Is that what we need? We need negative 22. So make both of them negative. Because a negative times a negative is a positive. And negative 11 plus negative 11 is negative 22. So then it is x minus 11 and x minus 11. And that's it. Okay. I'm going to do one of these. Which one do you want? 4? Okay. First times last. You need two things that multiply to 4 and add to 4. 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. So it's b plus 2 and b plus 2. Is this making a little bit of sense? All right. Let me show you a different weird thing that might happen. If you feel like you're not good at this yet, that's okay. We're going to practice it a little bit later. Let me show you something else. This thing called the difference of squares. Am I zoomed in? I think I'm zoomed in. Difference of squares. Okay, this is kind of like a little shortcut that we do all the time. And you use this shortcut when you have one. Well, let me ask you this. What's different between one that looks like this and all the ones that we've been doing? What's different? There's no middle number. That's the difference. There's no middle number. So when you see one that does not have a middle number, and the things are being subtracted, this is what I want you to think about. I want you to think about the difference of squares. Let me show you what it means. First, we got to think about square roots. You guys have any square roots memorized? Did you do that in middle school? No? Well, let's write down some square roots real quick. Where do I want to write them? We need some square roots. What is 2 squared? 2 times 2. 4. You guys know what squaring means, right? Multiplying it by itself. What's 3 squared? 9. What about 4? 16. What's 5 squared? 5 times 5 is 25. 36. Or sorry, 6 is 36. 7 squared? 49. 7 times 7. What about 8? 8 times 8. 64. 9 squared. 9 times 9. 81. 10 is easy. What's 10 times 10? 100. Okay. And then we talked about one just now. 11 squared. 11 times 11. 121. And what about, anybody know 12? 144. Those are your perfect squares. Those are the numbers that we're probably going to use the most. So if you don't have those written down somewhere, I would write those down. Those are perfect square numbers. And we're going to use them a lot. So these are all the perfect squares. We're going to use them a lot. When you have one that looks like this, missing a middle piece, you're subtracting, here's what I need you to ask yourself. I need you to ask yourself, what is the square? Well, let me ask you this. What's the leading coefficient of this thing? What's in front of everything? X squared, but what's in front of that? A 1. No, come on. 1 is in front of that. Okay, so if you have one that looks like this, I need you to ask yourself this question. What is the square root of this number? 1. What's the square root of 1? 1. It's pretty easy. Okay, so the square root of the first one is 1. We're going to call that A. All right. And then you ask yourself, what's the square root of the second number? Oh, hold up. That's squared. Square root is going backwards. So 9 is a perfect square, right? The square root of 9 is the number that if you square it, you get 9. So it's 3. So the square root of 9 is 3. We're going to call that B. Once you get A and B, here's what you do. You put it into this little equation. A plus B, A minus B. People causing problems out there or what? Out in the halls? What's going on? No. A plus B, A minus B. So it's, but here's the deal. You got to add an X in there as well. So it's going to be 1X plus 3, 1X minus 3. So maybe we could put X's after this too. AX. And can you just write 1X as X? So you could write it like this. And that's it. Let's do another one real quick. Let's do this one. Man, there's a 1 in front of that. So what's the square root of 1? Well, you know it's 1. It's easy. What's the square root of 36? 6. Go backwards. Square root of 36 is 6. So how would you write the factored form of this thing? Just jump down here. Yup. Crazy. That's it. Make a little bit of sense? Okay, why don't you try some of these other ones on your own? Ready, set, go. Okay, so these ones look a little bit different because now there's a number in front, right? It's not 1. So do the same thing, though. Look at this. Look at that number. What is the number? 9. What's the square root of 9? 3. So now a is 3. What's the square root of 4? 2. So remember, the pattern is this. Ax, oops, I forgot to write b. Yep, so b is 2. So it's ax plus b, ax minus b. So it's, instead of just x, it's just 3x. And 3x minus 2. And that's it. Okay, let's do another one real quick. What about, let's do this one. One underneath it. What's the square root of 25? And what's the square root of 144? So how does it factor? Oh. Relax. What? What? All right, so what is it? 5x plus 12. 5x minus 12. There you go. That's it.